Welcome. This is chapter 4, section 2, graphs of exponential functions. So these are the graphs now that we're going to go over. So here, again, we're going to examine just the basic function f of x equals b to the x. So notice that the output values are positive. You cannot get a negative output value. So as x increases without bound, your y will increase without bound. That is the same thing as saying as x approaches infinity, y will approach infinity. Or, we'll go with that. So when x tends to negative infinity, your y will approach 0, but it will never actually be 0. Your y can never be 0 because there's nothing that you would be able to raise to a power that would give you 0, since our b can't be 0. So that means there's a horizontal asymptote at y equals 0. This is all your general information on the graph. So here we will have a vertical shift. We will review that, b to the x plus d. We will do f of x equals b to the x plus d. We're going to make a slider for d. We'll go ahead and make a slider for b too. So our b can't be 1, so here we're just going to make a general b. I'm going to choose b to be 1.6. So it'll be exponential growth. Notice that as we move d, we get up and down movement. Notice that d is negative, it goes down. When d is positive, it moves up. So it moves in the same sign as d. So if d is positive, it will go up. If d is negative, it will go down. Now let's look at a decay function. Oh, right, b can't be negative. I'm going to have to... So we're going to look at some type of decay function. Oh. All right. There we go. Fraction. So 0.7. B is 0.7. Notice that it's also going to move up or down. Doesn't matter. This is just going to shift that whole thing up or down. Now, to move it left or right in the x, we're going to do b to the x minus c. So I'll go ahead and get rid of these. We'll do minus c. Here we go, minus c. We're going to make one for b and c. Okay, so here we have growth. Our b is greater than 1. Notice that we will move to the right when c is positive. Let me change these sliders. Go from 50 to 50. There we go. Negative. I want to capture those negative values. All right. Notice that when C is positive, it's going to move to the right. So that means that C in our equation would have a negative sign. So it's going to move the opposite direction of the sign. So that when C is negative, it's going to move to the left. So that you'll have x plus C. We'll move it to the left. Now you could always plot points. That's okay. You'll have a horizontal asymptote at y equals d, so whatever that plus or minus value is at the end. The shift is going to be negative c comma d. The shift will be up or down by d, and then the domain. So the domain is always going to be all real numbers, and the range is going to be d to infinity because of that asymptote. All right, so let's have a look at number 2 here. Try it number 2. So we will have a horizontal asymptote, and I'm going to say HA, at y equals 3 because we have this d here of 3. So here's 3. I'm going to say that's 3. We're going to have this asymptote, and I'm going to do it in a different color. And we will have, it's 2 to the x minus 1. So the shift here, the c is 1. So it will be it is 1, so it will be moved to the right by 1. So from this graph up here, I know this is going to be growth because it's 2. My b is greater than 1. So it will be growth. So the point I will have here, 0, 1, I will shift that to the right by 1 so that it will become the point 1, 1. And then I will shift that up by 3. So I will add 3 to the y. So it will become 1, 4. So this is 1, this is 3, this is 4. So it's going to become 1, 4. And this is where it will sort of start doing the curve. And then we will have 1b on our other equation. Well, 1 gets shifted to the right by 1, so that's now 2b, and then we're going to add 3 to our b, and our b is 2, so it's going to be 2, 5. And our equation will look something like this. The domain is going to be all real numbers. The range is going to be d to infinity. So over here, that is 3, and we will not include it, to infinity. Okay, stretches and compressions. So that would involve A. So it's going to be a stretch if the absolute value of A is greater than 1. So if A is not a fraction, it's going to be a stretch. If A is a fraction, positive or negative, it's going to be a compression. And I will show you that. We'll get rid of these. And we'll have A. All right, so I'm going to go ahead and make B growth. Notice that as my A gets positive, bigger and bigger and bigger and bigger and bigger and bigger, it's going to squish more towards the axis. And as it becomes a fraction, it's going to start going away. Let me see if I can get this. It will go from 0 to 0.9 in 10 steps. There we go. We'll let it come up with its own steps. There we go. So notice as it becomes more and more of a fraction, it pushes more and more out. Eventually it'll be flat if your A is 0. So what that means is I am essentially squishing it from, I guess, the top. So the vertical compression is where it would be pushing further and further. And the stretch would be like if I was pulling it, of course, a set amount of string is going to get closer and closer to that x-axis. So we are going to sketch this graph. So our A here is half. So the absolute value of A is less than 1. So we're going to have a compression, so it's going to go out more. And my B here is 4. So I know 2 points on my graph are going to be 0, 1 and 1, 4. Now, if I am compressing everything by half, I am multiplying all of my y values by half. So I'm now going to have 0, let me see. I will now have 0 half, and I will have 1, 2. Now notice my plus or minus d here at the very end is 0, so it will just look, it will be in the same place as just your standard equation. So you'll have an axis at y equal, an asymptote, a horizontal asymptote at y equals 0. Okay. All right. So of course the domain is all real numbers. The range here is d to infinity, and our d here is 0. So we are going to have a point at 0, half, so right here, and then a point at 1, 2. So that would be something like this. And I'll go ahead and I'll graph the original on here to kind of show you. So we would have originally had 0, 1. And then we would have had 1, 4. There we go. Notice how we just kind of squished it down more towards the y-axis. Now reflections. Reflections occur when our a is negative. So when we have a negative in front of our a. And that flips it across the x-axis. So if we originally had something like this with a positive a, we're now going to have something like this with a negative a. You can certainly explore that in Desmos. I recommend you do that. So number 5, we are going to graph the function that reflects this about the y-axis. So we have f of x is going to now equal negative 1.25x. So remember, our points for our original one are 0, 1, and 1b is 1.25. So 0, 1, and 1, oh, that's really little, so it's going to be like right there. Really close. So this is what we have, our original. Now, when we introduce the negative, we will have 0, negative 1, and 0, 1, negative 1.25. So that gives us negative 1, and just a little bit here, negative 1.25. So that we now have this. This is f of x equals 1.25x, and they wanted us to call this one g of x. And when you put the negative, I suggest you put it in parentheses, or else it will look like your b is negative, which will make it not an exponential function. So now we're going to write an equation for the function that is described below. We are given the horizontal asymptotes. Oh, and of course for above you would state your domain. The domain and the range. So if e to the x is compressed vertically by a factor of 1/3, then that's going to look something like this. 1/3 a e to the x. It is reflected across the x-axis. I guess we'll do plus d. And then this would be x minus c if we wanted to put it in general form. There we go. So we have the factor, the reflection, and then it is shifted down 2 units. All right, now in terms of the A and C, it doesn't look like it's multiplied by anything else. So I would assume it's 1. And since anything is not mentioned left or right, I assume C is 0. So that gives us f of x equals negative 1/3 e to the x minus 2. And that is it. So that was Chapter 4, Section 2, Graphs of Exponential Functions. Thank you, and I will see you in the next one.